Hello SkatterBenchers and welcome to a new video. On this channel, for those who don't know, we try to teach you how to do overclocking in a minimum amount of steps and time. This video will be a little bit different than the ones that we've done before, as we'll be focusing on one specific hardware component. The hardware component is the GeForce GT 710. This is NVIDIA's most low-end card on the market and it's dirt cheap. The cost of the card is about $50 US. That is also the reason why I was selected for the CheapazChips competition season 1 at OC-ESPORTS. The CheapazChips competition is a low-cost overclocking contest. It is organized by the overclocking community at HWBot and features the GT 710. At the moment of recording, the competition is already ongoing, and some of the extreme overclockers already put up some crazy overclocks. But today, we'll just keep it simple. In this video, we'll show you how to get competitive in a couple of minutes. We break up the process of overclocking in 4 steps. First of all, we'll figure out the maximum clock of the GPU memory. After that, we'll do the same for the GPU core. Then we put everything together and find the most stable settings. And as a last step, we'll actually join the competition. Let's get started. To do the overclocking, we'll be using 3 different tools. For the actual overclocking, we'll be using NVIDIA Inspector. To do the GPU monitoring, we'll use TechPowerUp's GPUZ. And then for the benchmarking, we'll be using GPUPi. You can find all the benchmarks and their download links in the description below. As a first step, we line up the GPUZ, its render test, and the NVIDIA Inspector tool. We make sure that the GeForce GT 710 is selected in the drop-down menu of GPUZ. On the Sensor tab, you will find all the relevant monitoring information, but we'll come back to that later. To enable the render test feature, just click on the little question mark on the right-hand side of the bus interface information. The render test puts a dummy load on the GPU, making it ideal for initial stress testing. On the Sensor tab, you can find information on the current GPU and memory clock frequencies, as well as the GPU load and temperature. In NVIDIA Inspector, we again make sure the correct graphics card is selected in the drop-down menu. Then we click Show or Hide Overclocking to enable the overclocking options. Once we have our options, we make sure the highest power state, P0, is selected. This ensures we are overclocking the card during high load, such as games or 3D benchmarks. In terms of options, we have 3 important items: base clock offset for the graphics core, memory clock offset for the memory, and voltage offset for the graphics core voltage. For more high-end graphics card, you can also tweak the power and temperature targets, as well as the fan speed. Our card is in fact passively cooled, so yeah, we won't be needing the fan option. Let's start the render test. Now you can see that the clock frequencies of the graphics card have increased to 954 MHz core frequency and 450 MHz memory frequency. The GPU temperature is a steady 38 degrees centigrade. When we increase the clock offset by one step of 20, the memory frequency increases from 450 MHz to 460 MHz. That's it, we're already overclocking. To find the maximum stable GPU memory frequency, we will gradually increase the clock offset until the render test creates system instability. At this point, we will know the upper limit of the GPU memory clock frequency. We are now at plus 340 clock offset, and it appears the system is still stable. However, in the render test, we can already see small visual imperfections. In the overclocking world, these are called artifacts. Adding one more step causes the system to lock up. We now know that plus 360 is the upper limit of the GPU memory. Let's reboot the system and move on to the GPU core. The overclocking process for finding the upper limit of the GPU core is very similar to the one for the GPU memory. We use the same tools to monitor and overclock, but instead we increase the base clock offset. Let's get started. Fast forwarding to the point where it gets interesting. When increasing the frequency from plus 460 to plus 480, the render test is still stable. But when we increase to plus 500, we see the render test lock up. That's a clear sign of instability. In addition, the screen goes blank for a fraction of a second, and the operating system informs me that the display driver has stopped responding. To recover from this, simply decrease the frequency by applying default settings. Since the voltage offset option is available, we can use it to see if we can perhaps increase stability by increasing the voltage. Keep in mind that you have to keep an eye on the GPU temperature when increasing the voltage. We are currently at a safe 55 degrees centigrade. We increase the voltage offset to plus 125 millivolts and try again from a safe setting. This time around, the system crashes at 480. No luck. Increasing the voltage further up from plus 200 millivolts gets us nowhere either. Time to move on to the benchmarking process. Now that we know the upper limitations of the graphics card, it's time to start the benchmarking process. This part of the overclocking process will take the most amount of time because there's no scientific rule that will tell you exactly how much lower the stable frequency is. As a rule of thumb, just start from a safe distance from the upper limit, benchmark it, check stability, and then increase the clock frequency. Note that the benchmarks will give you a performance indication. Pay attention to this number. Sometimes a graphics card will reduce the clock frequencies when it encounters thermal instability. Keeping an eye on the performance score will tell you if the graphics card encountered this kind of a limitation. Let's get into this. In this video, we will use the GPUPI benchmark and its 1B preset. We leave the benchmark open as we start our overclocking application, NVIDIA Inspector. In NVIDIA Inspector, we configure our initial overclock of plus 400 for the GPU core and plus 350 for the GPU memory. Once all the settings are applied, we close NVIDIA Inspector and launch the benchmark application. Now we wait for the benchmark to either crash or finish successfully. As we are waiting for batch 5 to finish, suddenly the benchmark indicates it has crashed. The calculation has been aborted. We close the benchmark and open NVIDIA Inspector again. This time we configure the graphics card to plus 450 for the GPU core, plus 320 for the GPU memory, and plus 100 millivolts voltage offset. If this is also unstable, we know the GPU core frequency is causing problems. If not, it may have been the GPU memory. We launch the benchmark and the waiting game starts. The benchmark has finished! Our time is 8 minutes and 5.186 seconds. From this point forward, we can increase the clock frequency and try to get even better scores. Now that we have our initial benchmark result, it's time to enter the competition. For this, we will need a valid verification file, a valid screenshot, and a system picture. Let's do the first one together. As we have the benchmark still open, launch an instance of GPUZ. This informs the moderators about the graphics card we used. Then, also open 2 instances of CPUZ. One to show the CPU information and one to validate the system memory information. Note that for competitions, additional verification may be required, so make sure to read the competition rules accurately. In this case, the verification screenshot also needs to include the CheapazChips competition background. Once this is set up, we go back to GPUPI and click the HWPOT menu. We select Submit Online. This feature allows us to directly submit to the HWP page from the benchmark application. Make sure to check Upload Screenshot. Leave the bottom options unchecked unless you want to manually select the processor and graphics card categories. To complete the submission, press Submit. To check the submission, click on the HWP URL hyperlink, which will open the submission webpage for you. In the sidebar, we find the ongoing CheapazChips competition. We learn that a system picture is required to enter the competition. We can do that later by editing the submission. Last but not least, let's have a look at the current entries in the competition. The third stage lists the GPUPI 1B entries. Scrolling down the list, we find that our current score of 8 minutes and 5.186 seconds would be ranked 14th in the competition. There's still a lot to improve. Looking at the score right above us, we find that a GPU clock frequency of 1454 MHz was used. Let's see if we can increase it further. This concludes our overclocking adventure with the GeForce GT 710. I hope you guys learned a trick or two and maybe you even want to get competitive. If you have any questions, just leave one in the comments below. I also want to give a shout out to Buildzoid, who's been competing in the same competition, but has been a bit more extreme already about it. If you want to learn about how to modify your car or how to use extreme cooling, I would definitely recommend checking out his videos. If you like this video, give it a thumbs up. If too much frequency scares the crap out of you, there's also a dislike button down below. If you want to see more overclocking action, just subscribe to the channel, and until the next one.